This lesson is on expected value. Here's the formula for expected value. And so we use some notation here where A is the payout or payoff and P is the probability. Let's look at an example here, and I think it'll help us kind of set up a problem and solve it. So it costs $4 to play the game. A die is rolled and you get $1 times the amount rolled. So if you roll a 2, you get $2. If you get a 6, you're kind of pumped and you get $6 back. Of course, it costs $4 to play. So what is the expected value? So you can start by making a chart. So I'm going to start that way. And we'll call this the payout, the payoff, and then the probability of that happening. So you have lots of different options here as far as, you could roll a 1, a 2, a 3, a 4, a 5, or 6. So the probabilities of those happening are relatively easy here. It would be 1/6, 1/6 of the time, 1/6, 1/6, 1/6, and 1/6. Okay. So actually, the hardest part about doing expected value is the payout, because it's not as easy as just saying, well, you get $1 if you roll a 1. Because it costs $4 to play, you actually don't get $1 when you win. It costs $4 to play, so you're starting $4 in the hole, and you get $1 back. So in my book, that would be -$3. So -$3 there. If you get $2 back, it costs $4 to play, that would be -$2. If you get $3 back, that would be -$1 total. 4 is a wash. Paid $4 to play, $4 back. You get $1 positive, and you get $2 positive here. So those are your payouts. That's probably the most difficult part about setting up the problem. And now it really just becomes relatively simple here. You basically just take this times this. You say 3 times 1/6 plus this times this. Sorry, that's -3 actually. Plus -2 times 1/6 plus, multiply these two guys, -1 times 1/6 plus 0 times 1/6. Sometimes I'll just write what 0 times that is, so it'd just be plus 0 here. And 1 times 1/6 is 1/6. I'm just going to write 1/6. And 2 times 1/6 is 2/6, or 1/3. So then to find the expected value, and usually the notation we use for this is we might say E of x, or x could be the name of the game, the event there that we're talking about. The expected value of this particular game is, and if we multiply this out and get that answer, that is the expected value. So just use your calculator at that point, multiply it out, and you got it. So this is actually a real casino game. And there are, on roulette, there are 36, 18 red, 18 black numbers, and then 2 green numbers. And if you place a $1 bet, you get $35 in return. So whatever you bet, you get 35 times the amount you bet back. So what is the expected value of a $1 bet? So we don't have to do quite as big a table for this guy. So the payout and the probability of that payout. And up here we're going to say the win and the losses. So for this one, the probability of winning, I always like to do the probabilities first. The probability of winning is, there are 36 plus 2, so there's 38 different spots. You have a 1 in 38 chance of getting your number called. So 1 in 38. Probability of losing is the complement of that, 37 out of 38. Now, the payout you would get. So let's assume you pay a $1 bet. You pay $1 to play. So you're down $1 to start with, but if you win, you get 35 times $1 back. So you get $35 back. So that's a net profit of $34. And the loss is, if you bet $1 bet, you don't win any money, so you lose $1. So then you would just, again, this now we do our expected value. So the expected value of roulette is equal to these two guys multiplied together, 34 times 1/38 minus or plus -1 times 37 38ths. And so you use your calculator and you get that total. So you're actually at -3/38. So anytime you have a negative value, I just want to stress this. So that's about approximately, I don't have my calculator here, but -8 cents or somewhere around there. So you're losing about 8 cents for every dollar you play. Every time you play, you're losing about 8% of your money. And that's about what a casino takes. Sometimes they take more or less than that. But the odds are always in their favor. It wouldn't make sense for them to be open if the odds were in our favor. So you lose about 8 cents. So if you spend $100 on roulette, you would expect to have about $92 left. If you spent $1,000 on roulette, you'd expect to have about $920 left. So you're going to lose money over the long run, but you're going to lose an 8% clip. So it's not as bad as, say, a scratch-off lottery ticket, which you'd lose more like 40%. This game consists of drawing a card from the deck. If you happen to draw a jack of spades, you win $60. It costs $1 to play, or the odds in your favor. Typically my students say the odds are never in your favor, but let's see what happens here. So I'm just going to set up the equation. The probability of winning in this game is 1 out of 52. And if you win $60. Plus, the probability of losing is 51 out of 52. All but one cards are loser cards. And then you win, if you win, or you lose, it costs $1, so you lose that. Oh, wait, be careful here. This is where you have to be careful. You actually don't win $60, right, because it costs $1 to play, so you actually only won $59. So just be careful to always take into account the cost of playing the game. So the payout is how much you get, subtract the cost. And then use your calculator and get that total. And actually this one ended up being positive. Of course, no casino is ever going to have this game. It's just not going to happen. They wouldn't be making money. That wouldn't be smart for them. Here's kind of a tougher problem. A game consists of rolling a die and you get $10 if a 6 is rolled. Anything else you get no money. What is the fair price to play this game? So if we start setting up our equation here, we might say something, okay, so we don't know the price here, but we're going to say you get $10. Well, actually, you don't really get $10, do you? Right? What do we have to subtract from the amount we get? The cost. So let's subtract cost, or C here. So that's how much the payout is if I win. The probability of winning would be, if you roll a 6, so that would be 1 out of 6 times. Plus, probability of losing is 5 out of 6 times, times the cost to play the game. That's how much you're going to lose, and so that's going to be a negative value, so I'm going to say negative C right there. And that's going to equal your expected value. Now, instead of just saying, expected value here, which is kind of our notation for that, I'm not going to put that because in this particular problem, we don't know what C is, but we kind of know what our expected value should be. Because when it says a fair price, it's basically saying that, remember, if a positive expected value, the odds are in our favor. If it's a negative expected value, the odds are against us, which is for all casino games. However, if we want a fair price to play a game, the expected value should be 0. So now I have an equation, and then it's just a matter of solving this equation and getting the right answer. So you might get something like 10/6, let's see, minus 1/6 c minus 5/6 c. So that actually ends up being 10/6. This works out to be negative 1c, so I'm going to put it on this side and say c equals 10/6. So c equals approximately, that looks like 1 4/6, or 1 2/3, 1.66 repeating here. So the fair price would be to charge about $1.67. Would be pretty fair there. That's as fair as you can get. And that is your lesson for today.